Hello friends, I welcome you all to the JCE Connect online video lecture series. I will be continuing with the second lecture on relative motion. I hope that you have followed the first lecture, gone through it properly, and also practiced the first example which we have solved. Today let's continue with further examples. So first example for today's class is a passenger train of length 200 meters is moving with a velocity of 90 km per hour, which overtakes a goods train of length 150 meters on a parallel path in same direction completely in 50 seconds. Determine the speed of goods train. So firstly, let us check what is the given data. Length of passenger train, which will designate as train A, is 200 meters. Length of goods train, which will designate as train B, is 150 meters. Velocity of passenger train, which will designate as VA, is equal to 90 km per hour. Velocity of train B, which is the goods train, is unknown, that is VB is equal to question mark. We have to here determine VB. So the schematic diagram there represents train A and B showing their length such that the train A has just overtaken train B. So now let's go ahead to find the velocity of goods train, that is VB. So firstly here we have to note that the velocity of train A is given in terms of kilometer per hour, which we have to convert it into meter per second, which is done as 90 into 1000 divided by 60 into 60. That 1000 converts kilometers to meters and 60 into 60 converts hours to minutes and finally to seconds. So we get the answer as 25 meters per second is the velocity of train A, which is a given data itself. Now let us come to the concept of relative velocity. So here we have to determine the relative velocity of train A with respect to train B. That is, the equation comes as VR is equal to VA minus VB. If you are able to recall, in previous example we have taken relative velocity of B with respect to A and our equation was VB minus VA, whereas here we are taking the equation in terms of the known quantity, which is the velocity of train A. So the equation comes out as VA is 25 minus VB. Therefore VR is nothing but, we got the equation as VR is equal to 25 minus VB. So now the total distance covered while the process of overtaking happens is length of train A plus length of train B, which is 200 plus 150, which is equal to 350 meters. I think the step is very much similar to the one which we have done in the last problem. Therefore, relative distance can be written as relative velocity into time, or other way is velocity is equal to distance travelled upon time taken. Directly you can substitute in that way also. So substituting the given values, we have to concentrate here on finding VB. So we have the equation 350 is equal to 25 minus VB into 50. So doing the cross multiplication process, we get 50 VB is equal to 900. Therefore VB comes out to be 18 meters per second. Okay, 18 meters per second, and directly we can multiply with the factor 3.6 to convert it into kilometer per hour. Okay, directly we can multiply with the factor 3.6. Now how that 3.6 has come is 60 into 60 divided by 1000, which gives you the direct factor for converting meter per second to kilometer per hour. Similarly, I think 0.27 comes out to be a factor for reverse conversion. That is, if you want to convert from kilometer per hour to meter per second, I think the factor comes out to be 0.27, which also you can use directly. So here we have found out the speed of train B, that is VB, which is 64.8. So now, what are the probable mistakes you can do in this? Firstly, while writing the VR equation, that is relative velocity equation, if you take VB minus VA, okay, if you take VB minus VA, then what happens is, in the equation becomes 350 is equal to VB minus 25 into 50, and that 25 multiplies with the outside 50 and goes to the left hand side, and you will get a value which is not 900 but more than 900. Okay, one more thing which you can remember is, one is a goods train, one is a passenger train. So of course passenger train has to be fast, and velocity of passenger train is given as, 25 meter per second. So what answer you get in this case has to be lesser than what? The velocity of the passenger train, because passenger train is the one which is overtaking the goods train. So remember this point very much carefully. Okay, remember this point very much carefully. We have to get the answer VB such that it is less than VA. So this is a small example, but such examples are asked for 6 marks, sometimes for 8 marks in your VTO question paper. Let's come to a next example. I think this will be a last train example, because from yesterday we are into the train. Okay, so now what data we have here is, we have again 2 trains, train A and B. One is 240 meters, other is 300 meters, which are moving on parallel tracks in opposite direction. So note down here the changes, the trains are moving on parallel tracks but in the opposite direction. The velocity of A is twice that of B. Okay, velocity of A is 2 times that of B, and 20 seconds is required so that they pass each other. Here overtaking doesn't come because they are not going in the same direction. Here they are in the opposite directions. So here 20 seconds is the time which is taken for them to pass each other completely. So what we have to find here is, we have to find the velocity of the trains. So again, let VA be the velocity of train A in positive direction. Now it is up to us. We are saying that the faster train is in the positive direction. Let VB be the velocity of the other train which is moving in the opposite direction. Therefore relative velocity again with respect to A is VA minus VB, which is equal to VA minus of minus V by 2. Now how that V by 2 has come? Because in the statement it is given that velocity of A is twice that of B, that is 2 into VA is equal to VB. Again I am repeating, 2 into VA is equal to VB, or VA is equal to VB by 2, is equal to VB by 2, or V is equal to V by 2 in terms of overall velocity. So we get a relative velocity of 1.5 into V. Here one more important thing is, minus sign has come twice, hence the answer is in plus. One minus is with the formula, other minus is used because the trains are moving in the opposite direction. It is very simple, and this problem is very much similar to your first example. Only the difference here is that the trains are moving in opposite directions. So now the relative distance which we require is again addition of the length of the trains, which we get as 240 plus 300 is equal to 540 meters, and this distance is covered in 20 seconds. Therefore again applying the relative distance is equal to relative velocity into time relationship, and cross multiplying we get V as 18 meters per second or 64.8 kilometer per hour. Therefore, Vb is half of V or half of Va. That becomes 9 meter per second. Sorry, there is a printing mistake here in the PDF. 8 divided by 2, sorry, 18 divided by 2 should come as 9, but it has been printed as 10. Please make the correction when you are writing it in your notebook. And further we can convert it into kilometer per hour. So this is a very easy example where we have found out the velocity of train A as 18 meter per second and velocity of train B as minus 9 meter per second. That minus doesn't indicate negativity and all, it is only indicating that both the trains are moving in opposite directions. Now let's come to a different example, last one for the day. Need not worry, because as per your feedbacks you want short and sweet videos, and we have made an attempt to do it. So here we have a different problem. The problem says hailstones falling vertically with a velocity of 6 meter per second on to the deck of a ship steaming at 10 meter per second. Find the direction of motion of the hailstones as felt by an observer standing on the deck and its apparent velocity. So now many times what happens is, reading the example, you cannot get the feel, because once we have solved the train examples you can imagine. But here this example is also easy. Only thing is that you have to read the example carefully, understand it. Nothing, a ship is there, ship steaming means ship is moving at a speed of 10 meter per second. It is raining and you are having a hail stones, what we call, I think we call it as Gara in Marathi and Anekal in Kannada, hopefully I am not wrong. And that person is standing on the deck of the ship and he is observing. So what we want to find here is the direction of motion of the hailstones which are falling along with the rainfall as felt by the observer who is standing on the deck and its apparent velocity. Okay, so when you are standing in a say open terrace or a balcony in the rainfall, the rain doesn't come down exactly perpendicular to your surface or your slab. Okay, it comes down with some angle, and when you observe it, okay, and you want to find at what angle is the rain coming, okay, and what is the velocity with which it is coming. This example is the same one for the relativity which I told you all. Okay, so now the important thing here is, firstly, let Va be the velocity of hailstones which are falling from the sky. Okay, next let Vb with the velocity of the ship. Okay, Vb with the velocity of the ship. Now the ship is moving. Okay, the ship is moving horizontally. So let Vb be represented along horizontal axis. The hailstones are falling down from the sky. So let that hailstone which is coming down be represented along the vertical axis moving down, and let Vr be the relative velocity. Okay, let Vr be the relative velocity or apparent velocity as it is termed, which we have to find here. So again I am repeating, Va is the velocity of the hailstones which are falling from the sky. So it is represented along downward y-axis. As the boat is moving forward, it is represented on the horizontal sea surface. I am representing it along the x-axis as Vb, which is 10 meter per second, and in this case we get a resultant velocity or relative velocity, okay, which is represented by Vr. So this is the scenario. So let Vr make an angle of theta with the vertical Therefore, we get the components as VR sin theta is equal to 10 and VR cos theta is equal to 6. Now this is simple, just we are resolving VR along x axis and y axis, along which we know the forces. So dividing 1 by 2, we get tan theta is equal to 10 by 6 or theta is 59 degrees. That means the person who is standing on the deck, who is observing the hailstones falling from the sky, he feels that those are coming at what angle? 59 degrees. They are not coming straight downwards, but they are coming in an inclined way, and that angle is 59 degrees. Now we can use the next equation, VR sin theta is equal to 10. So substituting the value of sin theta, we can get the value of VR, which comes out to be 11.67 meters per second. That means the hailstones are falling from the sky at an angle of 59 degrees as per the observer, with the velocity of 11.67 meters per second. So now this is an example where we are dealing with two things. One is the hailstones which are falling from the sky vertically downwards, and the boat which is moving on the surface of the ocean in a horizontal plane. So now if the speed of the boat changes, these values will change. That's what you experience if you are moving faster in the rain. You feel that the rain is hitting you harder, the rain droplets are hitting you harder. That's because of your speed also. It is not that if you move fast the rain will fall faster. Okay, it is not that, but this is the concept of relative velocity. So this last example I have taken a next level example in which concept changes a bit. So in the next class we will solve few more examples and conclude this topic. Hope all of you are safe, healthy, fit and fine and taking the necessary precautions. Please go through the examples, solve them in your regular classwork notebooks, or if you don't have them, please make a notebook and solve these examples. See you all for the next class. Thank you.